Welcome, all you badass mathematicians. Today we're going to talk about linear approximation, and our overall goal is going to be to approximate the square root of 5. So let's start off by graphing this. Let's graph a function that includes the value square root of 5. So let's graph f of x equals the square root of x, which is going to look something like this. And this is 5, which makes this square root of 5. And that makes this 2. So the idea here with linear approximation is we're going to be looking for a line that's going to give us a reasonable estimate for the value we're interested in. Here we're interested in the value of square root of 5. Now the reason we're using a line here is because of a property called local linearity. So a function like this is going to appear linear the more and more you zoom in on it. I challenge you to think of basic functions like x squared, x cubed, the square root of x, the cube root of x, and keep zooming in on parts of the function where it's defined. As you keep continuing, the function should appear straighter and straighter. So the idea here is we're going to use a line at a nearby neighbor of 5, and because we're looking at a tangent line constructed at a nearby point, it should be a reasonable approximation. So here we're going to pick the point 4, 2 to construct our tangent line. That's a crooked tangent line. I can do better than that. All right. Oop. Alrighty, there we go. That's a way better tangent line. Okay. So as we can see, this point here is roughly near the value of square root of 5. So if we call this tangent line L of x, then this point here is 5 comma L of 5. And notice that tangent lines aren't actually the only type of approximation that we can do. So if we actually go over and look at 9, comma 3, which is another point on our graph, we can actually construct what's called a secant line. A secant line that intersects our original function f at exactly 2 points, whereas a tangent line intersects our function x at exactly 1 point. So the slope of our tangent line, of course, is going to be our derivative of f at the value 4, whereas the slope of our secant line is just going to be the average change between 4 and 9. So let's look at our secant line first. So to define a line, we need to know a point, and we also need to know a slope. So let's use 4 comma 2 as our point. So y minus 2 equals m times x minus 4. And so we can calculate the slope of this line. We know 2 points on the line, so we can just directly compute 3 minus 2, which are our y values, divided by 9 minus 4, which are our x values. So we get 1/5 is our m. So we're getting y minus 2 is actually equal to 1/5 times x minus 4. So let's call this s of x. So this gives us s of x, which is y, is equal to 1/5 times x minus 4 plus 2. And now we can plug in to get our approximation. So s of 5 is going to be equal to 1/5 times 5 minus 4 plus 2, which is equal to 2 plus 1/5. So here's one of our approximations, linear approximations, using the secant line. So next, let's explore what our tangent line approximation is going to look like. Oops. Tangent line. So similarly, we can start off with point slope form and use our point 42 again. And in fact, here notice that we cannot use the point 9.3 because that is not a point on our tangent line. So our only option here is to use the point we constructed our tangent line with. Oops. Okay. We're gonna just go ahead and substitute in the value directly. X minus 4. And then m is gonna be equal to f prime at 4. So f prime of x using the power rule is gonna equal 1/2 x to the minus 1/2. So f prime of 4 is going to equal 1/2 times 4 to the negative 1/2, making f prime of 4 equal to 1/4. So then this means L of x is going to be equal to our slope 1/4 times x minus 4 plus 2. So we can see that the biggest difference between our lines that we've constructed is the slope. So this slope is the slope of our secant line is slightly less than the slope of our tangent line. So then this makes L of 5 equal 1/4 times 5 minus 4 plus 2, making L of 5 equal 2 plus 1/4. So as we can see, our secant line actually lies below our curve. So this is going to be a underestimate, while our tangent line actually lies above the value we're trying to find. So this is going to be an overestimate. So in conclusion, what can we say about the square root of 5? Here's the square root of 5. And we know that it is going to be less than 2 1/4. And we also know that it's going to be greater than our estimate from our secant line, which is 2 plus 1/5. All right. There we go. Y'all have a wonderful day.